So finishing up our explanation of the Mann-Whitney U-test, which again is a non-parametric two-sample test of the median. We took our two samples, which they could have the same or different lengths, okay, and we combined them into a single vector that containing all the measurements, and we sorted the values in ascending order, associated each of those values with each sample, and then ranked the values from 1 to n1 plus n2. The third step was to compute W's, the rank sums. So the rank sum for sample 1 was, in this case, 23.5, and we calculated the rank sum for sample 2, which happened to be 31.5. Then we computed our U values. So U from sample 1 is equal to the rank sum from sample 1 minus 1/2 n1 plus 1/2 n1 times n1 plus 1, which again was the sum of the ranks had all the measured values in sample 1 been smaller than all the measured values in sample 2. So U1 measures how different the rank sums are from that extreme case. And for sample 1, we got a value of 2.5. From sample 2, we got a value of 21.5. Now the next step is to take the minimum U. So compare the two values of U and take the minimum, and that becomes our statistic. And in that case, the minimum U was 2.5, and this is our statistic. And this is, I guess this is step 5. And then step 6, of course, we have to define alpha, our significance level. And in this case, let's say it's 5%. And then we have to find the critical value of U. And the critical value is the U value for N1 values in sample 1 and 2 values in sample 2, and alpha, which in our case is U6, 4, and 0.05. So we can look this up in our Mann-Whitney table, our critical value table for the Mann-Whitney test. And there are two tables that are posted online. The first is for alpha is equal to 0.05. The second is for alpha is equal to 0.01. In this case, we need alpha equal to 0.05. N1 is 6. And N2 was 4. Right? So our critical U value is 2. And we found a U of 2.5, so U, which is 2.5, is greater than U6, 4, 0.05. So U was not small enough to reject our null hypothesis, right? If U were closer to 0, then we could reject the null hypothesis, but it's not. So we cannot reject H0. Now, if you recall, and let's go back and look at our data values, a lot of the measurements in sample 1 were in fact less than a lot of the measurements in sample 2. And that's clear if we look at the sample IDs associated or in our ranked vector. You can see a lot of the ones appearing higher up in our rankings or having lower total rankings than sample 2. So based on this visual inspection, one might suspect that the population of sample 1 has a lower median than population 2. But what our test showed was that this result is, while it's unlikely, it's not so unlikely to meet our significance level of 5%. So our random sample here falls within a probability greater than 5%, and so we could not reject our null hypothesis. So this concludes my presentation of the Mann-Whitney U-test, our two-sample test of the median.